Welcome to The Explainer. What if I told you that the entire AI revolution, all this incredible technology that seems so complex, is actually the accidental result of one shockingly simple instruction? Let's get into it. First, let's just take a second and really think about the magic that's happening right now. We have machines, actual computer programs that can create, that can reason, that can communicate with a fluency that feels, well, it feels almost human. So you have to wonder, right? How is this even possible? It feels like we must have spent decades painstakingly programming a whole universe of knowledge into these things, teaching them every single rule of grammar, every fact, every little bit of nuance. But, and this is the key, we didn't. Get this. We never gave an AI a lesson on how to be poetic. We never taught it about metaphors or sunsets. And yet, it can come up with lines just like this one. So if we didn't program the genius in, where on earth did it come from? Well, the answer, and this is the wild part, is in the one core instruction we gave these models. And believe me, it is way simpler than you could possibly imagine. It has nothing to do with poetry or chemistry. It's much, much more basic. That's it. No, seriously, that is the entire secret. The whole foundation of the most advanced AI in the world today is built on one single task. Just predict the next word. You know when you're texting and your phone tries to finish your sentences for you? It's basically that. Just that supercharged. It's the same idea, but scaled up to an absolutely unbelievable degree and trained on a massive chunk of the internet. And here's where the magic happens. To get really good at that one simple guessing game, the model is forced to learn about the world. I mean, to correctly guess Paris, it has to know a fact about geography. To guess peanut butter, it has to understand a little bit of cause and effect. It learns all this stuff not because we told it to, but because it's a side effect of just getting better at predicting. Now, if the idea is so simple, you might be asking, why now? Why did this take so long? Well, this one simple trick wasn't perfect right out of the box. Getting this good at it has been a long, long journey. The whole history of modern AI is really just the history of getting better at prediction. We started with simple counting. Then we gave the models a basic memory. And now, finally, we have systems that can process information at a massive, massive scale. The first language models, these things called n-grams, were basically just bean counters. They didn't really learn anything. They just looked at a word or two and, based on pure statistics, calculated which word was most likely to pop up next. So, for example, an n-gram would see the word new, look at its giant statistical table and say, well, about 80% of the time the next word is York. Simple, kind of effective, but deeply flawed. The problem was they had the memory of a goldfish, a total lack of context. It could get the next word right, maybe the next two, but because it couldn't remember the beginning of the sentence, everything it wrote would just fall apart into complete gibberish. So then, around the 2010s, came a truly revolutionary idea. Somebody asked, what if we could give the model a memory? And that was the whole concept behind something called a recurrent neural network, or RNN. So an RNN works sequentially. It reads a word, and it kind of tucks a little note away into its internal memory. They call it a hidden state. And then it uses that memory, that little note, to make a better guess for the next word. This was a huge, huge step forward. But this memory was, well, it was a bit leaky. Imagine reading a really long book, but by the time you get to the last chapter, you've completely forgotten the main character's name from chapter 1. That was kind of the problem here. The memory would just fade. Okay, so this is where everything changes. This is where things get truly interesting. We had these models that were getting better at prediction, but they were still pretty limited. And then came the breakthrough. The moment when getting better at one simple thing created this explosion of unexpected new skills. A new type of model called the transformer came along, and it allowed us to build these things on a scale that was just unimaginable before. We fed them huge portions of the internet. And remember, the goal was still the same boring thing. Just guess the next word. But the result? Nobody saw it coming. All of a sudden, these models started developing skills we never, ever explicitly taught them. Things like translation, coding, logical reasoning. They just emerged. And why? Well, it turns out that being able to translate or reason are incredibly useful strategies if your only goal in life is to be the world's best word predictor. And this brings us to the absolute core idea: compressed understanding. Think about it. What's the most efficient way to store all the information on the internet so you can predict what comes next? You can't just memorize it all, that's impossible. The best way is to understand the underlying rules, the concepts, the relationships. The genius was an accident. It was just a byproduct of extreme data compression. So the final piece of this puzzle wasn't some brilliant, elegant new algorithm for intelligence. It was a really simple, almost brute force idea. What if we just make it bigger? In 2019, GPT-2 came out with 1.5 billion parameters, and at the time that was an absolutely astonishing number. It could write coherent essays, and it was a really clear sign that something big was on the horizon. But then, just 1 year later, GPT-3 arrived, and it wasn't just a little bigger. It was over 100 times larger, with 175 billion parameters. The leap in ability was just staggering. We're talking poetry, computer code, reasoning. It was a whole new ballgame. And that's when the secret was out. The scaling hypothesis was correct. The path to smarter AI wasn't a more complicated goal. It was about chasing the same simple goal, predict the next word, but doing it at such a mind-boggling scale that the model was forced to develop a genuine, compressed understanding of our world just to keep up. And this leaves us with a truly profound question. I mean, we set out to build a better autocomplete for our phones, and we ended up with something that can reason, create, and communicate. If a form of genius can just emerge accidentally from such a simple directive, what does that tell us about the nature of intelligence itself? It really makes you think, doesn't it?